In this puzzle, 2 circles and 1 semicircle are located within a square. All 3 inner shapes make contact with a tangential line. The smaller of the circles is defined as having radius small r and the larger, radius big R. The puzzle asks, what is the value of big R divided by small r? No explicit measurements are given, so we begin by defining a variable for the side of the square. We choose this length because the square both encloses all elements, but also relates them, which will become clearer later. We start by finding small r in terms of x, and notice that, if lengths for a right triangle can be found in terms of both r and x, it'll be possible to find r in terms of x. The triangle in question has a similar triangle within. The scale factor for the base can be applied to the side to discover the side length of the smaller triangle. From here, we can calculate the length of the hypotenuse using the Pythagorean theorem. We can use the Pythagorean theorem again to discover small r in terms of x. After simplifying and putting into the form of a quadratic equation, we can apply the quadratic formula and run through the necessary algebraic manipulation. This includes expressing an expression as a square in order to dissolve a root. We end with 2 solutions, however we can only accept a positive value as small r cannot have a negative value. Moving on to the other circle, we can calculate the length here that we have provisionally identified as p. In finding a value for big R in terms of x, we can identify a triangular area that perfectly inscribed the larger circle. We find 2 expressions for this area, one in terms of x, and one in terms of big R. Setting them equal, and solving for big R, we calculate a value for big R. We obtain 2 values. However, only one of these is applicable in context, because big R cannot be larger than the length of the side of the square x. Therefore, we can discard 3x over 2 in favor for x over 4. Having now obtained a value for both big R and small r, we can calculate the division to find the answer to this puzzle.